Alright, this is like my third time recording since the first time when I recorded on Friday, the audio didn't work. So let's just get this quickly done. So first off, what we're going to do to solve this circuit is we're going to calculate the REQ. And to do that, we have to picture it as these two. So this parallel plus this afterwards. So in order to calculate that, we're going to do 27. We're going to break it up, get this first, then add it to this, and then we're going to add these together. So 27 plus 54, sorry, I'm a little bit congested right here, to the negative 1. And then this plus 12, and then all of this to the negative 1. And then plus. So once we get that, we're going to add that answer plus 15 to the negative 1, all to the negative 1. And then there we're going to be able to get 10 ohms of REQ, but we still have to add this. So that's going to make it 20 REQ equals 20 ohms. So after that, we know that if the REQ is 20 ohms, we just do the battery, which is, sorry, I didn't write that down, is 40 volts. So then we do I equals V over R, and we get the I battery is 2 amps. Now using that, we can just go for the low-hanging fruit. So if we use the pucks, we know that this gets 2, or here is going to have 2, and then it breaks up. So to do that, so we know that since this is going to get 2, we can plug in 2 for the table. And then, let me just scroll down. So if this is 2 amps, then we know that the V equals I times R, so this is going to be 20 volts. 2 times 10. Oh yeah, these are all in ohms, and this is volts, and this is amps. So after we find the first one, we know since there's a total current in the system, a total voltage of 40, then we'll know that this right here will get the remaining 20 volts because this has 20, and you can picture this as like series. So 20, so 40 minus 20 is equal to 20, and then to get so we know this one has 20 volts, and then to get the amps, we just do 20 over 15, which equals about 1.33 repeating. Alright, so after that, we now know that this has 1.33. That's how much current is going in, or we can just say about 1.3. So we know that this has to get the remaining 0.7 current flow amplitudes of current, which means right here is going to all come back to 0.7. So since we know this has 0.7 currents, we could plug that in for resistor 3. And 0.7, sorry, these are hard to read. 0.7 times, because V equals I times R, 12 is equal to 8.4 volts. And then lastly, we just subtract So we do, to get the, since it's a whole system, we can picture it as like the voltage gets distributed. So we have 40 minus 20 from here, and then minus 8 again, minus 8.4 equals 11.6. So that's the total current, I mean voltage that's gonna be given to R1 and R1 and R3. So 11.6, 11.6, and then we just divide out. So I equals V over R, and this is gonna be 0.43. And then this one's gonna be 0.21. It'd be more precise than like it would equal 0.7 if I used 1.33, but I'm just going with the slightly less precise answer. So that's how you solve the total system. We just label these R ohms, V volts, I A. Alright, there you go.